Hello students, and welcome back to another algebra video. Pause the video and try the problems on the screen just like usual. These highlight questions from the last video. So pause it, try it out, check your solution, and unpause it to do it with me. Okay, so solve the equation, check your solution. We won't be checking our solutions, or at least I won't. Because we want to leave time for everything else that we have to do. So, first, I notice that I have parentheses, which means I must distribute. Parentheses first, distribution first. Let's change colors here. This 3 goes to the x, and the 3 goes to the 1. 3 times x is 3x. 3 times 3 is positive 3. And then everything else comes down. And let me draw that line there so I can see what's what. I'm going to zoom in here so that we can see a little bit better. Okay. And then remember, I have an apple, an orange, and orange. I can put these together. Get 3x plus 9 equals negative 9. I want to get rid of the 9 on this side, so I'm going to do the opposite of plus, which is minus 9 from both sides. We have 3x equals negative 18. And then, of course, the opposite of multiplication is division. So we will divide by 3 on both sides. And x equals negative 18 divided by 3 is negative 6. And remember to plug that back in to check your work. Okay, next question. Parentheses first, always distribution first. So I am going to give that negative 2 to the y, and then to the negative 4. So we have 13 equals negative 2 times y is just negative 2y. Negative 2 times negative 4 is positive 8 plus 3y. Okay, and now we have an apple, an orange, and an apple. So let's put these apples together. 13 equals, let's see, 3y minus 2y, positive y, plus 8. Okay, and then we know what to do next. To get rid of this plus 8, we're just gonna minus 8. Subtract 8 from both sides. 13 minus 8, 5. And 5 equals y. Awesome. And of course we can plug back in, check. Okay, last problem. Parentheses first. We have 4 times negative 4 times 2m is negative 8m. Negative 4 times positive 5 is negative 20 minus 3m equals 35. And let's draw our line there. Okay, we have an apple, an orange, and an apple. So let's put those together. Negative 8m minus 3m. That is negative 11m. The minus 20 comes on down, and the 35 will come down as well. And now we got to get rid of the negative 20, so we will add 20 to both sides. Negative 11m equals 55. And now we divide by 11 on both sides. So m is equal to 55 divided by 11 is negative 5. And of course, we can check by plugging our answer back in. Okay, wonderful. So now, remember, check your answers, but we're going to move on to what we have for today. And what we have for today is the first part of section 1.3, which is about solving equations with variables on both sides. So we saw one example of that in the last video. We're going to see more examples in this video. So our learning target is that you know what a variable is. We've talked about it before, but you need to know what it is. The success criteria is that you can solve equations with variables on both sides of the equal sign. Not too bad. I think we should have a fun time of it. Okay, so important information. Solving equations with variables on both sides. To solve an equation with variables on both sides, simplify one or both, whichever is necessary. Simplify one or both sides of the equation, if necessary. Then use inverse operations. We have seen this multiple times now. Inverse operations will always help us when solving an equation. To collect the variable terms on one side and the constant terms on the other side. Remember, a variable is letters, things like X, Y, M, P, typically letters, but remember that a variable can be anything. We can use a smiley face. We can use a Greek letter alpha. We can use the Greek letter theta. Many different things can be variables. All that matters is that we don't know the value of it. X could be 3, could be 5, could be any number. Its value varies. Variable. That's where the name variable comes from. Okay. And then constant terms. Remember that constant terms just mean numbers. It means that it's just a number. So 5, 6, 12, you know what numbers are. So what you want to do is you want to get variables on one side of the equal sign and your constants or the numbers on the other side of the equal sign. And then you can get rid of everything and get the variable all by itself. Okay, so let's jump right into example 1. Notice how we have an X on this side and an X on that side. So we have a variable on both sides of the equation. Now, what we're going to do is we need to get all of our variables on one side. We need to get all of the X's on one side of the equation, all of our numbers on the other side of the equation. So, because when I look at this side of the equation, all I see is negative 9x. That's a variable with a coefficient, but it has an x. So I am going to decide that all the x's are going to go over here. And all of the numbers are going to go over here. Now, I know a lot of people, they need x equals this. They can't stand it when you get something equals x. Both of those are true. Whether you say 3 equals x or x equals 3, it doesn't matter. That means the same thing. So, it doesn't matter which side you get x on, as long as x is on one side and the numbers are on the other side. It doesn't matter which side they're on. If you want x to always be on the left side, go for it. You're not going to be wrong. You just might be taking a few more steps than we would. That's okay. Whatever you like to do. Okay. So, now that we've talked about that, I'm going to get x on this side because it's going to take the fewest number of steps. It's going to be quickest because we already have an x over here. And just an x over here. So in order to do that, I need to move the other x. I need to move it over here. Excuse me. And remember that we talked about moving the x over to the other side means that I need to do the opposite of it. So right now I have minus 4x. So I'm going to plus 4x. I'm going to add 4x to both sides. So it goes away over here. Remember, minus 4x plus 4x just goes away. And now I have 10 equals negative 9 plus 4 is minus 5x. Remember to keep the x. And now you know what to do. we've seen these types of equations before. It's a single-step equation. So I have negative 5 times x. The opposite of times is dividing. So I'm going to divide by negative 5 on both sides. 10 divided by negative 5 is negative 2, and negative 2 equals x. Now, we need to check our solution. So I'm going to take the original equation, 10 minus 4x equals negative 9x, and let's shove negative 2 in there. So 10 minus 4 times negative 2. Remember that putting things in parentheses just means times. Negative 9 times negative 2. Okay, so now we have 10 minus 4 times negative 2 is negative 8. And that is equal to negative 9 times negative 2, which is positive 18. Remember, minus a negative, they come together and become happy. Minus a negative is positive. So 10 plus 8 is 18. And does 18 equal 18? It most certainly does. So x equals negative 2 is indeed correct. Awesome. Awesome, awesome. Let's double check that we were right. X equals negative 2 and 18 equals 18. Mwah. Beautiful. Okay, example 2. Distribution and variables on both sides. So now we have to use the distributive property. Now I know this might look a little intimidating, maybe a little scary. Don't let it be scary. It's not as bad as it seems. What we're going to do is we're going to focus on this side of the equation first, and then we're going to look at this side of the equation, and then we'll talk about where should the x's go, where should the numbers go. But for right now, remember in that first slide we saw, it said to simplify. First step is to simplify each side of the equation. Then we'll start moving things around. So right now, let's just simplify, and we're going to distribute on both sides of our equal sign. So first we'll do this left side. 3 times 3x is 9x, and 3 times negative 4 is negative 12. Yay! Simplified on that side. Okay. And now we'll do 1/4 times 32x. So remember, 1/4 times 32x, that's like 1/4 times 32 times x. And remember that 1/4 times 32 is it's the same thing as 32 divided by 4, which is 8. So 1/4 times 32 times x is 8x. Okay, so we have 8x, and then 1/4 times 56. Again, this is like 56 divided by 4, which is 14. So we have plus 14. Awesome. Okay, now that our equation is simplified, now we can start moving things around. So here I have an x. I have an x on both sides, and I have a number on both sides. So it doesn't matter if you want x's over here and numbers over here, good for you. It really doesn't matter which way you do it. Something that you might want to think about is keeping x positive. Does it matter? Do you need to keep x positive? No, you will get the same answer. If you choose to move the 9x over here, you will get the same answer as if you choose to move the 8x over here. You can do it whichever way you want. Some people find it easier to keep the x, the coefficient of x, positive. So if I subtract 9x from both sides, 8 minus 9 is negative 1. And some people don't like the negative there. So what some people do is say, I'm going to subtract the 8x from both sides. So that when I do that, I have 9 minus 8 is positive 1x minus 12 equals 14. Doesn't matter. Again, you'll get the same answer if you minus 8x or if you minus 9x, you'll get the same answer. It's whichever way you like to do it best. Okay, so we subtracted 8x from both sides, this canceled out, and we are left with this equation. So, the next thing to do is to get x by itself, we need to do the opposite of minus 12, which is plus 12. And if I do it to one side of my equation, I gotta do it to both sides of the equation. So this goes away, and I am left with x equals 14 plus 12, 26. Ta-da! All right. This doesn't tell us to check our solution. How odd. Let's do it anyways, just to make sure we know how. All right, I'm going to erase some things on the side here so that we have enough space. Okay, original equation. 3 times 3x minus 4 equals 1/4 32x plus 56. So now we have 3. 3 times 26 minus 4. 1/4. 32 times 26 plus 56. Woo! Okay. 3 times 26, I don't know that in my head, is 78 minus 4 equals 1/4 times, 32 times 26 is 832 plus 56. 78 minus 4 is 74. And 832 plus 56 is 888. 3 times 74 is 222. And 888 divided by 4 is 222. Is 222 equal to 222? Yes, it is. So x equals 26 was correct. I see why they didn't tell us to check our solution, because that was a tiny bit complicated. But good practice. Always good practice with PEMDAS. All right, wonderful. Let's check and make sure we were correct. X equals 26. Beautiful. Okay. In summary, so now we have learned about one-step equations. We've learned about two-step equations. We've learned about multi-step equations. We've learned about the distributive property. And now we've learned about when we have variables on both sides of the equation. So we will summarize what we have learned so far by saying, here are the steps for solving linear equations. So, here are several steps you can use to solve a linear equation. Depending on the equation, you may not need to use some steps. So these are the steps for like the most complicated linear equation. You won't always have the most complicated linear equation. Sometimes you'll have a simple one. So pay attention to that while you're working on your problems. But first, use the distributive property. Like we talked about, always the distributive property comes first. Then you want to simplify the expression on each side. So this could include combining like terms. Okay. Step 3, variable terms on one side, constant terms on the other. X over here, or x's, so like 5x or whatever it is, x is on one side of the equation, numbers on the other side. Okay. And then, of course, the last step, isolate the variable. Remember that, let's do a different color. Isolate means x by itself, or the variable by itself. And then, of course, our wonderful step 5, check your solution. Always check your solution, why not? Okay, so if you want to pause the video and write those down, that would not be a bad idea. And if you're one of my students, you're probably required to pause the video and write that down. Okay, questions. If you have questions, remember to ask them. Questions are good things, and if you sit with those questions inside you and you never get them answered, learning later on will be difficult. More difficult than it needs to be. Okay, here are some practice problems. There are quite a few. Remember that these are not necessarily the questions that your teacher will assign. It might be some of these, it might be none of these. So, these problems you can use to practice. But yeah, make sure that you do the homework your teacher assigns, and not necessarily these ones. Okay, alright, and as usual, let's end our time with a launch. We'll launch you off to the rest of your day. This one says, act as if what you do makes a difference. It does. And that is from William James. So, act as if what you do makes a difference. Because it does. What you do makes a difference. And what you do can make a positive difference or a negative difference. You can do good things, you can do bad things, right? So when you, even something as simple as saying, oh, I really don't like her hair, like, that makes a difference. What you do makes a difference. You saying, oh, I don't like her hair, even if she doesn't hear you, the person next to you is probably going to go, oh yeah, you're right. And now people are talking about how her hair doesn't look nice. That's not a nice thing. It makes a difference. And what if that does get back to her? What if Suzanne hears about you not liking her hair, and now Becky also doesn't like her hair? Well, Suzanne doesn't feel very good. So, what you do makes a difference. And even if it's just like smiling at somebody as you walk down the hall or as you walk to the grocery store or something, even if it's just a smile or a wave, that also makes a difference. I had a friend in college tell me that it meant a lot to her that I smiled at her every time I saw her, even if we didn't talk, if we were just walking down the hall and I smiled at her, that it really made her day. So what you do makes a difference. It does make a difference. So act like it. Don't act like, oh, it doesn't matter. Like, no, it does. Everything you do matters. And it can matter in a good way or a bad way. That is up to you. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.